Now let's think, why does this thing go to the right? Does it really move to the right? We have a negative sign in front of the time. Does that really make it move to the right? We can do it, so we're going to prove this by coding it. We're going to do programming now. Yay. Now let's see, we're going to do programming. Look at everybody's face. No one cares, okay. So if you're a computer science person, we're not really going to do programming. We're going to do MATLAB, okay? So it's not really coding. If you're pre-med, this is a different kind of coding. This is a program that's going to make a plane wave. Look, all we did was we defined k, and we said it's 0.2, and omega is 0.2. And here we're making an x-axis from 1 to 100 meters, say. And we're saying we're going to calculate the y at 100 times, right? And then we're going to make a movie. All right, we're making a movie. We're saying for time is 1 to 1,000 seconds. Let's write this equation. And here it is. Y equals 5. That must be the amplitude. Times sine of k. That must be the wave number. Times x minus omega times t. Right? So this thing is a function of x. X is like, 1 to 100. So it's calculating this shape, y of x, for all position for a certain time, and then plotting it, and then really plotting it right now. Draw it now. So if we plot that in real time, let's see what it does. Oh, it moves to the right. Look, there it goes, to the right. It's a sinusoid. Its amplitude is 5. It's moving to the right. Wow. Let's see, why is it really moving to the right? Let's do this. Let's plot it. Let's let phi equals 0. So it's really just a sine kx minus omega t, right? Oh, God, I got shit everywhere. And now let's plot it at t equals 0. So at t equals 0, it's just a sine kx. So I can draw a sinusoid. Watch this. Thank you. Sinusoid. Okay, what is its amplitude? Oh, it's a. It goes to plus a here. This is for people just catching up here. It goes to minus a there. That's the origin. Sinusoid. Ooh. More like that. There we go. And now that's at time equals 0. What if we let time go forward a little bit? Oh, I should do colored chalk. No, never mind. T equals 1. Okay? Let's let time get bigger. What happens when time gets bigger, but say we want to find this place where the 0 is going to be. Where's the 0 going to be? If time is bigger, like t equals 1, but we want kx minus omega t to be 0, what does x have to do? X has to also get bigger, because the time is negative in there. Right? T gets bigger, like t equals 1. We want that to be 0. So x has to get bigger. So in the little part under the sign, because the time is negative, when it grows, this has to grow if we want to keep up with this point. So we go over here. Like that. So which way did it move? It moves to the right. A negative time constant here makes the graph move in positive x. Just accept it. Okay? I'm trying to explain it a little bit. If you don't like to understand it, if you don't know what I'm talking about, just accept it. If there is a minus sign here, it moves in positive x. All right? Now, using your amazing powers of deduction, if I put a positive sign there, which way will it move? Negative x. Here we go. I can't believe we're doing this live. Oh, my God. Look at that. It moves in negative x if I put a positive sign there. Dude, what if I put a multiplication in there? Oh, man, this is going to be cool. How do I stop it? I've never done this before. Let's see what happens. Oh, my God. I've made something amazing. Look at that. I have no idea what that is. Okay. Don't put a multiplication sign in there. That is not part of the class. That is just for fun. My idea of fun. Is the amplitude the same with bigger time? What? That doesn't make any sense. Is the amplitude the same with bigger time? No, in the wave we're describing, the amplitude is constant. We'll talk about the amplitude changing in a little bit. But yeah, A is a constant here. Okay, because there's no decay. Remember, for the damped oscillator, I'm layered here. For the damped oscillator, it went down in time. My God. But here we don't have any damping on these waves. They go forever. Okay. Okay. One page down. Here we go. 10 to go.